Hello, I am Euclid from World Gold Silver, and today I'll talk to you about Euclid's theorem and prime numbers. So first of all, what is a prime number? A prime number is any number that is divisible only by itself and by the number 1. So for example, the numbers 2, 3, and 11 are all prime numbers. 2 can only divide by 2 and 1, 3 can only divide by 3 and 1, and 11 can only divide by 11 and 1. An example for a number that isn't prime is 12. Because 12 can divide by 2, it can divide by 3, it can divide by 4, and it can divide by 6. These numbers are called the products of 12. That means that you can use only multiplication between these numbers and get to the number 12. The next thing I'll talk to you about is the actual theorem. The theorem was published by Euclid in his work, The Elements, in the year 300 BC, and it starts like this. First of all, let there be a list, any list of a finite number of prime numbers. For example, P1, P2, all the way to Pn, while n is a finite number, which means it's not infinite. The next part is the A is equal to the product of the multiplication between all these numbers. So P1 multiplied by P2 all the way to Pn. And the third constant we need to make is D, which is equal to A plus 1. So D has two options. Either it's a prime number or it's not a prime number. If D is prime, which means it has no product except for itself and 1, that means that there is a prime number that does not exist in the list, since it's not part of this product, and since this list is fully theoretical and has no actual numbers put in, that means we can do this with any list of numbers and prove that there are an infinite number of primes. But on the other hand, if D is not prime, that means that there is at least one number, at least one prime number that will be the product of this number. So for example, we call it x, which is a prime number. Now, x, as we said, because it's a product of d, it can divide d to a whole number. But if x is not in this list, that means it cannot divide a by a whole number, since it would be in this product and would be divisible. So now I will prove that x cannot be divisible of a, cannot be a product of a. So first, as we said, d is divisible by x, and for a number to be divisible by two numbers, it must be divisible by the difference between the two numbers. For example, if we take the numbers 36 and 24, they are both divisible by the number 6. For example, 36 divided by 6 is equal to 6, and 24 divided by 6 is equal to 4. And also, as you can see, the difference between the two numbers, which is equal to 12, is also divisible by 6, because 12 divided by 6 is equal to 2. Now, we will use this same rule on this. So, as you can see, to prove that x cannot be divided by x, we have to prove that x cannot divide the difference between the two numbers. The difference between d and a is equal to a plus 1 minus a, or is equal to 1. And now, as we know, 1 is not divisible by any number. It is only divisible by itself. And since 1 is not a prime number, it is not divisible by any prime number. And so x cannot be divisible by a, which means it's not in the list. Which again proves that there are an infinite number of prime numbers. I chose to talk about this theorem because I feel like it's really simple and easy to understand, and it shows the beauty and ingenuity of math, even in like 2,000 years ago, in 300 BC. And I thought that would be really interesting to talk about.